In this video, we're going to learn how to find the vertex of a parabola. So before attempting this lesson, there's a few things you need to be comfortable with. First, you need to know what is the vertex of a parabola. You need to be comfortable with graph transformations, completing the square, and factoring out the greatest common factor. So all things that we've learned before, but just make sure you kind of quickly refresh on those because I'm going to go through them a little bit quicker in this video because there's a lot of slides to cover. All right, so first thing, recall about graph transformations. So we learned this earlier on. All right, we start with our normal x squared graph. That's this one with the blue dot here. If I add 2 in the parentheses and subtract 1, that's going to move my graph left 2, down 1 into this graph. And you see that's actually the vertex. That kind of starting point is the vertex of my quadratic. So knowing these values basically tell me the vertex. All right, let's look at another example. So in this one, we subtract 1 on the inside, subtract 2 on the outside. That's going to move us down 2 and right 1. And you can see we end up at the vertex of that quadratic. And the last one, subtract 2 on the inside, add 1. We're going to move up 1. Subtract 2 moves us right 2. And you see we end up at the vertex. So knowing how graph transformations work will help us find the vertex of a quadratic. And there's this thing called vertex form. And it's called vertex form because by just looking at the equation with doing no work, just kind of some understanding of transformations, we can find the vertex. Because if our quadratic is in this form, all right, this part right here looks just like our transformations. The a value is not super important right now. The left and right part tells us the x value of the vertex. The k part tells us the y value of the vertex. So it's called vertex form because I don't have to do any work to find the vertex. So let's just say I had this problem and I'll find the vertex. My vertex, this is the x value of the vertex, but it's opposite because remember transformations happen opposite for the things on the inside. So that's -5. This is the y value of the vertex, 6. All right, so that's simple when it's already in vertex form. As long as you remember that this is opposite, then you got the vertex. All right, here's one for you to try on your own. Find the vertex of this quadratic. All right, I'll show you the answer in 3, 2, 1. The vertex is -2, -8. And that's because opposite, and we move it down 8. All right, so unfortunately, of course, not every quadratic function is not going to be in vertex form. We've seen this happen a lot. It hasn't always been in vertex form. However, we can change it into vertex form by completing the square, right? Vertex form looks like this. So if we create this perfect square, then it's going to be in vertex form. So really, we just have to do completing the square, and then we can do those simple examples we just did. All right, so we're going to find the vertex of this. So I'm going to go through this problem first. I want to show you the general strategy, and then we'll do some more examples. So completing the square with a function is a little bit more difficult than with an expression, with an equation, sorry. Because with an equation, we can do things to both sides. But here, there's really nothing to work with on the left-hand side, so we have to do it in a little bit different way. So what we're going to do is the first thing we're going to do is just focus on these parts. We kind of want to ignore the whole number. And when we did completing the square before, there was never a number in front of x squared. So we're going to get rid of that 3 somehow. But we can't just divide the equation by 3 because it's not an equation, it's a function. All right, so how can I do that? Instead of dividing by 3, what I can do is take that 3 and I can pull it out by factoring. So I'm going to factor out, and this is why at the beginning I said to be comfortable factoring out the greatest common factor because that's the first thing I do. Factor out whatever that a value is. And now what we're going to do is just do completing the square on this part. All right, so remember completing the square, we identified the b value. In this case, b is 2. We divide that number by 2 to get 1. We square that number to get 1. So now what we're going to do is in order to create a perfect square, we know we have to add 1 to this expression that we have. And that's going to create a perfect square. But there's one problem. When we did this before with completing the square, we added 1s to both sides of the equation. But again, we don't have an equation, so we can't do that. So the way we fix that is we added 1, but we really don't want to add 1 because then we change the function. So we added 1, and then we're just going to subtract 1. Really weird thing. This happens a lot in upper level mathematics, not much in algebra. This is kind of the only time we do this thing called adding 0. We add a number, and then right away subtract it away because we didn't actually add anything, but we're going to make our equation just look a little bit different. And what we're really going to do now is just focus on these three. All right, that little minus one that we had to do is just the fact of keeping our function the same. But those three are our perfect square. They turn into x plus 1 squared. Again, that 1 comes from that one. We still have this minus 1. And now this whole time we had this 3 that we kind of had at the front that we didn't really want, but now we can put it back because we can distribute it to this part and to that part. And we can combine those two like terms at the end to get minus 2. So we did all that. And now we just got to the point we were in the earlier examples. Now we can finally find the vertex of the quadratic. And again, this step is pretty simple. You switch the first number to a negative. You keep the second number the same. All right. So it's a lot of work, but the very last step, pretty simple. All right, so in general, here is the strategy for finding the vertex of a quadratic. We just focus on the x terms, and we're always going to factor out that a to just give me x squared. Then inside the parentheses, we're going to complete the square by adding and straight subtracting that formula b over 2 squared. Then inside the parentheses, just the first three terms are going to turn into our perfect square. We're going to distribute that a value back into the parentheses, and then simplify and identify the vertex. So it's a lot of steps, all right, but you can keep track of them all. It's all things you've done before, just done in a slightly different way. All right, so let's do another example. Find the vertex of this. Again, first thing I'm going to do is going to separate the x's away from the number, and I want to factor out a. So my function now is going to be the negative 2 is going to be in the front. I'm going to get x squared because the negative 2 is gone. If I divide 8 by negative 2, I'm going to get negative 4x. So that's the big first step, factoring out that a value. Now I'm going to take b is the number next to x, it's negative 4. B over 2 is negative 2. B over 2 squared is positive 4. So now I know in the parentheses, I need to add positive 4 to turn into a perfect square. But in order to not change the function, I also need to subtract 4, add it, then subtract it right away. Really strange thing to do, but it's what's mathematically correct. And now I focus just on these first 3 terms here, because those first 3 terms are the ones I'm actually most interested in. They're the ones that are going to turn into this perfect square. That's the whole reason I added 4 in the first place. And again, this minus 2 comes from there. Right, now this negative 2 distributes into there, into that number that I had to subtract earlier. It's going to be plus 8, plus 3. And I combine those last 2 like terms at the end to get my vertex form for my quadratic. All right, but now I'm still not done. I still have to actually solve for what the vertex is. The vertex is positive 2, positive 11. All right, so it's a long process, but again, it's things you've done before. As long as you keep track of the steps, you can find the vertex. All right, so here's one for you to try on your own. Go ahead and find the vertex of this quadratic, and I'll show you the answer in 3, 2, 1. And the solution I got is the vertex is negative 1, negative 3. So again, you can look through and see all the steps. All right, factoring out a, completing the square, factoring as a perfect square, distributing, combining like terms, finding the vertex. All right, so all the steps are there. You just have to follow along and make sure you're careful with your negatives and kind of what you're adding and subtracting. All right, so now you can go ahead and practice finding the vertex. All right, if you want to, I have a few more slides where I'll show you a different way to find the vertex, but if you're happy with the way we just learned, you can do that, but I'll show you another way. This other way requires you to memorize a little formula, so if you would rather do that, it might be a little bit easier, but if you just want to memorize the least amount as possible, you should be happy with the way we just learned. All right, so we're going to learn method 2 for finding the vertex of a quadratic, and it uses 2 facts. The first fact it's going to use is the x value of the vertex is always given by this formula. X equals negative b over 2a. And we use the other fact that we've known for a long time. If I know an x value, I can find its y value by just plugging it into the equation. So this second method for finding the vertex is going to require you to memorize this first little formula. But then once you figure out that number, you just plug it in, and it's order of operations rather than completing the square. All right, so let's find the vertex of 3x squared plus 6x plus 1. The x value of the vertex is always given by negative b over 2a. b is 6, so it's going to be negative 6 over 2 times a is 3. And again, just that's b next to x, that's a. This would be c, but we don't need it. This is negative 6 over 6, and that's negative 1. So the x value of the vertex is negative 1. To find the y value of the vertex, now I take this negative 1 and plug it in for x. And when you're plugging things into a quadratic, just make sure you're careful with order of operations. The most common mistake people make is doing this multiplication before this exponent, but we do the exponent first. Let's do the same color. Then we do the multiplications. And then 3 minus 6 is negative 3, plus 1 is negative 2. All right, so now I know the x value of the vertex and the y value of the vertex, so my answer is just negative 1, negative 2. All right, so this method definitely looks like a lot less work, all right, but it requires you to memorize some extra stuff. All right, so it's really up to you if you prefer this method or not. I have a few more examples to show you. All right, find the vertex of this. All right, the x value of the vertex, negative b over 2a is negative 8 over 2 times negative 2. And that's 2. So my x value of the vertex is 2. The y value of my vertex is now, when I plug that in, again, just remember to do the exponent first. See, negative 8 plus 16 is 8, plus 3 is 11. So my final answer is going to be 2, 11. So I find the x value by using this formula. I find the y value by knowing, if I know an x value, I'll always find the y value the same way, plugging it into the function. All right, so here's one for you to try on your own. Find the vertex using this other method. All right, I'll show you the answer in 3, 2, 1. And the final answer I got is negative 1, negative 3. So again, using that formula and plugging it in. So here's one way you can actually make this process a little bit easier. To do this process, you have to have it memorized that x is negative b over 2a for the x value of the vertex. This is kind of the separate thing you have to memorize. But there's another thing you already, hopefully, have memorized, and that's the quadratic formula down here. And if you look at the quadratic formula, if you just look at the first half of it, kind of get rid of that square root part, that's the vertex, negative b over 2a. So actually, it's not an extra thing you have to memorize. All right. So if you kind of remember this connection and you just write the quadratic formula down, you can always get back to the x value of the vertex. And the y value of the vertex just comes from your understanding of graphs and functions, that if you have the x value, you plug it in to get the y value. All right, so now you have two different methods to find the vertex of a quadratic. Do whichever one makes you happy, which one you think you'll be the most successful. All right, and go and practice.